Раз. Раз. Bir, ikki, uch. Раз.
Olib yurishim kerak. Yo'q. Shunaqa qilaman iloji. Mana shu mashina ustidami? Mana shunaqa ro'yxatda shekilli. Ketayotganimda mana bu yog'ini o'chirib tashlab ketaveraymi chetga? o'chirilganmi, yoqilganmi o'zi? Today, our topic is bending. Is slice is visible or not? Last time, when we have solved the exercise, I told you one part I didn't explain in purpose. Yes? When you have drawn the diagram of shear and moment, you had a constant, linear, or moment can be solid, right? When moment will be linear? When moment diagram will be linear? When diagram of moment will be linear? When? No. Linear, this one. Which kind of force? Distributed force, yes? Yes. If we have a distributed force, it means that shear force diagram will be constant and our moment diagram will be linear. It means that if we have a distributed load is affecting our shear force will be linear and moment will be parabolic. We have a condition, parabolic can be written like that or like that. Yes? When? That's why you are given two different conditions. This one is the for positive shear. This one is the for negative shear. As I told you, if we have a line, upper part is the positive, down part is the negative. Yes? If we have a shear force diagram, it's increasing on positive side. It means that our moment diagram slope will be drawn like that. If it is decreasing, our slope will be like that. So, if our shear force diagram is the minus side, it means that our moment will be decreased. Yes? Like that. And if it is decreasing more, it means that our moment will be opposite of this one. This one is the plus side, this one is the minus side. It means that if it's getting more negative, your slope will be always like that. Did you understand? More negative. Next one. If slope is changing more negative side to the negative side itself, less negative side, it means that our slope will be inside. Slope becomes less negative. If our slope being less negative, it means that our slope will be changed in this way. This one is the more negative, this one is the less negative. Here also same. This one is the more negative, this one is the less negative, less positive. This one is for positive side and this one is for negative. That's why, yes, when you are drawing the shear force and moment diagram, you should follow this, okay? Mainly, you should follow what? This one and this one. If you follow this one, you will not have any problem with drawing of shear force and moment diagrams. Did you understand? So, today, I will start bending. Bending. What does it mean, bending? No. Yes. He's right. Don't check the direct definition of the word, okay? When you are checking the word definition in mechanics, check like that from the internet, okay? You are right. So, you already know what does it mean beam, right? Beams are usually long compared with their cross-sectional dimensions, straight, prismatic members. What does it mean prismatic? You remember, what does it mean prismatic? What does it mean? Yes, I told you. What does it mean prismatic? Prismatic means that constant cross-section area. Beam, cross-section doesn't change along its plane, this one. Cross-section is this one. It's not changing, yes? Did you understand? Can you answer me when I ask you? What does it mean prismatic? Yes? Prismatic beam, it means that our cross-section will not be changed. So, prismatic members that support transfer loads. Which kind of loads? Which affecting to the beam perpendicular to its plane. This one, P and WX. These are the transfer loads, which are loads are perpendicular to the longitudinal axis. Longitudinal axis is always X. Yes? And loads on a beam cause it to bend. Of course, if we have a P affecting from this side, our beam will be changed and bending will happen. Did you understand? No. At the edge. P is affecting from this part, okay? Because of this one, it's changing. This one we will call bending. What is the name of this beam? Who said yes? Cantilever beam. Why cantilever? Because one side is fixed. If one side is fixed, we will call cantilever beam. Okay? Bending, did you understand? Please write down this part, okay? Loads on a beam, starting from here and here. You don't need to draw the picture. But if I ask you, please write down the definition of a beam. You should draw this one. You can draw it easily. This one is the cantilever beam. For example, P is affecting. This one is the before bending, and this one after bending, it will change its position, something like that, yes? And this one, example for bending. Yes. Please write down as soon as possible. And also, the applied loads cause the initially straight member to deform the curved shape. This one is the straight condition. This one is the deformed condition. This one we will call deflection curve. Okay? After bending, we will have a deflection curve or the elastic curve. Can I move on to next slide? No, starting from the loads. Loads up from the loads until the end. You are almost done, right? Yes. They will cut it. If I'm not explaining, they will cut it. So, we will consider beams that are initially straight and have a longitudinal plane of symmetry. What does it mean? Longitudinal axis is the x-axis. And longitudinal plane of symmetry is this one, because around this plane our beam is symmetric. Yes, that's it. You understand this one, right? What does it mean? This one is a longitudinal axis. About this longitudinal axis, our beam is symmetric. And this plane we will call longitudinal plane of symmetry. And we also can have in material fibers. What does it mean, fibers? Yes, exactly. In each material, for example, wood, it has some kind of fibers, right? And all fibers will be longitudinal because it's placed around the x-axis. You don't need to write this one. So, as an example, we took beam. Which kind of beam? What is the name of this beam? Simply supported beam. When we will call simply supported, if we have two supports on both sides, this one is a pivot, this one is a roller, and we have a P load, which is far from our support A length. Yes, this is the length of arm. So, in this part, our diagram for shear. Is it understandable for shear? Because P is going up. Yes, it's going up. Until here, we don't have any force. It will go down. And until here, we don't have any force. It means that it will change just through the line. It means that it's equal to 0 here. So after that, we have again P, and it's going to down to minus P. As this is one is the minus side, our direction will be downward. This one is the upward. It means that our diagram is correct. And when we will have a pure bending, when our shear force is equal to 0 and moment diagram has a constant amount. Yes? As I told you, in order to draw the moment diagram, we will calculate the area of this one, right? If this one is a P, this one is a A. Area of this one will be P multiplied by A. PA, this one. I told you, on external support, we will have a moment will be equal to 0. Yes? From 0, P multiplied by A, and it will change this direction. Why? Because we don't have any shear. That's why it will be constant until here. After that, it will be again linear. And this moment we will call, this moment is a constant and it can cause to the pure bending. Okay? If I ask you, you can answer me. Pure bending happens when V is equal to 0. It means that moment will have a constant amount, which is equal to P multiplied by A. Did you understand? And next slide, we will cut small part, HK, okay? In order to find the flexural strain. We will cut and we will learn. So, if we have a beam and moment is affecting from both sides, this moment is the bending moment, right? Upper part will be in compression. Down part will be in tension. It means that our length in upper part will be shortened, right? And down part will be elongated. But we will have one more fiber which doesn't change its length. It cannot be shortened or it cannot be elongated. And we will call this one neutral axis. this one. And the plane which can create the neutral axis, we will call neutral surface. Compression or tension doesn't happen in this neutral surface. And this one is the neutral axis. Did you understand? So, in this case, this definition is same. Neutral surface exists between the upper and lower surfaces, always. And it doesn't have any shortened or elongated conditions. So, this surface is called neutral surface. And intersection of this surface with any cross section, it will be neutral axis of the section. That's it. So, what about the flexural strain? What does it mean, flexural strain? You already remember what was the normal strain? It was equal to delta L divided by L. Yes? I will continue this part here. This one is the neutral axis. It means that my length doesn't change, right? This one is delta x. But this one is shortened. It means that it will change, delta x prime. This one angle is the delta theta. And this one is O. Why I took like that? After deforming the shape, it will create the circle. Yes? If I continue this, can create the circle. Yes? Here. And this one is the center of this circle. Yes. From the center, I will draw the line which will be the radius. Right? So, this one, we will call the rho. And this one is the y. What does it mean y? It is the distance from the center to the neutral axis. From the top of the, not center, sorry. From the top of the beam to the neutral axis. This one is the y, okay? From the top of the beam to the neutral axis. So, this distance will be equal to what? Rho minus y. Do you agree? So, in this case, let's rewrite. What was the formula of arc length? I told you last time with simple example. This one was the S, this one was the theta, this one was the R. S is equal to R multiplied by theta. Yes? In this case, I will rewrite again. Delta x is equal to what? Delta x is equal to rho multiplied by delta theta. Delta x prime is equal to rho minus y multiplied by delta theta. Yes? E is equal to what? Ex strain is equal to delta x prime minus delta x divided by delta x. From here, I will rewrite it again. Delta x prime is equal to this one. Y delta theta minus rho delta theta divided by rho delta theta. I will remove from all parts delta theta. Yes? From the dominator? Yes. And we will have what? We will have rho also will be removed. Minus y divided by rho. It gives us what? It gives us the flexural strain or bending strain. It's written here. Same. And we will call rho what? We will call what? Radius of curvature. Okay? Distance from the neutral axis, it will be radius of curvature. And we also have one more definition. The center of this arc, O, is called the center of curvature. If I ask you, what is the center of curvature meaning or radius of curvature right now, you can explain with this simple example, right? Please write it down. Let me know when you are done, okay? Did you finish? I will move on to next slide. Before moving on, we have here curvature. What does it mean? Curvature is the Greek letter kappa is a measure of how sharply a beam is bent, and it's related to the radius of curvature, and k is equal to 1 over rho. Rho is the radius, okay? Keep it in mind. K is equal to 1 over rho. This one is the curvature. No? It is just parameter connected with the radius. Y öyle uçurmaz o. You already remember relationship between the normal stress and normal strain by Hooke's law, right? Sigma x is equal to E multiplied by Ex. In this case, epsilon x equal to what? Yes, minus E multiplied by Y over rho. Yes? From here, 1 over rho, can I write like a K? Yes? It means that it will be minus E multiplied by Y multiplied by K. This one is the formula of normal stress in beams. In the case of bending. In general, the resultant of the normal stress in beam consists of two components. Resultant force acting in the x direction. What does it mean? I have explained it when we had a beam. If one side is cut, we will have a normal force and shear force and also moment, right? Yes, this normal force can cause us normal stress. So that's why resultant force acting in the x direction. This one is the one of the components of normal stress in the case of bending. Okay. And second one, resultant moment acting about z axis. This one. Or we also can have inner moment. How? Inner bending moment. We can find how? Force multiplied by distance, length of arm. Yes? And why stress is going inside in this part? Why stress is going outside? Because when moment is acting in this direction, inside part is being compressed. Down part, bottom part will be in tension. That's why our stresses has directed inside this part, and blue color is our stresses is outside. It means that if it's in compression, our stress will be minus. If it is a compression, our sigma x will be minus. If it is tension, our normal stress will be positive. Please write down this formula, okay? That one, normal stress. I already told it, wrote it here. Yes? Because compression. Yes. Yes, lower side can be compression, and in this moment, bending moment will be minus. Bless you. Our topic is not finished yet. I will explain. I will prove. So, the pure bending, neutral axis must pass through the centroid of the cross-sectional area. I will prove this definition. Why it will pass from the center of mass. Okay? I will prove it. If I wrote dF is equal to sigma x multiplied by dA, do you agree? Yes, right? Because normal stress is equal to F over A. So, I will write free body diagram about the x direction. In this example, we took one small part which has a cross section dA for cross section of the beam. Okay? If this one is the y, this one is z, it means that our x will be this side. Yes? So, right now, our force will affect to this body perpendicular to this cross section. Did you understand? We have a force which can cause to the stress which is affecting perpendicular to this cross section. It means that fx I will rewrite in x direction. We have only df which is affecting to the dA. Oh. Sigma x is equal to what? From previous slide. Sigma x minus e y divided by rho and dA. I will put it out some constants. Which kind of constants? E and rho. Why? E is the Young model. It's constant. What about rho? Rho is the unlimited because it's radius. It can be changed always, right? It doesn't depend on our cross section area. So E divided by rho A y. This one gives us what? You have learned yesterday. Not that one. Later you will tell me this one, okay? Not this one, because this one is y, not y squared. This is the first moment of area. You want to tell me j, right? Yes, it will be y squared. It is the second moment of an area. This one is if it is the y 1 degree, it will be first moment of area. Okay? We don't have sort. So this one is the first moment of area. From applied mechanics, I already have asked some students. You have learned how to find the center of mass. Is equal to what? I will write the formula. If you don't understand, we will solve the exercise. For next class, you will understand better, okay? How to find the center of mass. And you will remember, I will remind you. It's equal to what? Divided by dA. This is the formula for finding the center of mass along the y direction. So, as this, I am taking the sum of the all horizontal forces should be equal to 0 from the free body diagram, right? It means that this one will be equal to 0. If this term is equal to 0, it means that this coefficient will be 0 and this one also will be 0. If this is 0, this part also will be 0. It means that our will pass always our center of mass of our cross section. This is the proof. Okay. It means that if we have a rectangle shape, it is center of mass here, right? If this one is the beam, our neutral axis will pass always through our plane will be like that. And this one, inside part, we will call this one inside part, not this one, okay? Inside part, we will call neutral axis. We will have exercise when you are given the cross section. First step to find the center of mass of the body. Okay? After finding this one, you can decide where our neutral axis is placed. It will be same line with our center of mass. That's it. But different cross section, of course, we will have a different center. For example, if we have a T-shaped beam, something like that. Of course, its center of mass will not be in the middle, or not here, not here. It will be somewhere here. It means that its neutral axis will go through with this line. If I draw from this side, it will be something like that. Our neutral axis will be here. Did you understand? Yes. Yes. Why you forgot this one? You have learned it from applied mechanics. Yes, what does it mean? If we took it out from the integral, it will be just A itself. So, A is the area. If you have a simple cross section, it will be simpler. For example, I will rewrite. This is just for y coordinate. What about the x coordinate? It will be same. A x dA. I A dA. It gives us what? This one is multiplied y multiplied by A divided by A. But if we have a complex shape, something like that, we will divide into two parts. It means that this formula will be changed. How? This one will be sum of them yn an. This one will be x, right? Yes. X and an. And this one will be sum of the an. After that, we can find the center of mass for complex shapes. For circle, this one, for this one, we know where is the center of x and y. I will not explain this part. You should remember it. This definition comes from, you should spend one lecture to write it down. But we will go to the exercise and we will use this formula. How to find center of mass. It means that we will have complex shapes. Okay? By using complex shapes, it will not be just circle, it will not be just triangle or rectangle. It will be a bit complex. For example, I shape, L shape, T shape beams. Okay? How we will find? We will divide into two parts. If it is T shape, we will divide into two parts. First, we will calculate for this one. Second, we will calculate for this one. Okay? And we will take the coordinates y and x. And we will calculate the x how far from our center of our coordinate. And same. Because we already know where is this center of mass of rectangle? In the middle. And it will divide the sides into two parts. Yes? This one. If this one is the B, this one is the A. This one is equal to A divided by 2. This one equal to B divided by 2. What about the center of mass of triangle? It will be, yes, at intersection of meridians, right? Yes? And circle, it's very easy. In the middle. Yes? Did you understand? So, please write down this part. Okay. Write down this one. And you will write Azam. You will tell me next part what is the integral y squared dA. This one will be second moment of inertia. Last time I wrote this one, it was J, right? Did you understand? Write down this definition and the proof. Did you finish? Can we move on? Can we move on? Did you finish? I will write again. df is equal to sigma x multiplied by dA. You already understand, right? What about the dm? dm is equal to what? F multiplied by it will be what? F multiplied by y. Why? Because I told you F is affecting this direction, right? And in order to find the moment, force should be multiplied to the length of arm, this distance. Yes? Moment is equal to. So you understand this one, right? dm is equal to F multiplied by y. I will take again as the force. I will take the moment along that direction. Yes. Along that direction, our moment. So, if we have a, I told you, if we have a positive normal stress, it means that negative moment. Yes? It means that it will be equal to minus sigma x dA, right? What is the formula sigma x? Yes, y. Sigma x itself. So I will write it here. First of all, minus y sigma x dA. We also have, yes, we will write. We will write. We will write. Don't worry. I will write. And we also have a moment, internal moment, which is affecting along the z direction. Here. Yes, we are coming to this point. We have a moment this side. If it rotates about the z-axis, it has some kind of this rotation. Yes? If upper part is tension, down part is compression, it will be, moment will be minus. So I will write minus m. Will be equal to 0. From here, m is equal to what? Sigma x is equal to what? So, dA. As we have a dA, we will use integral form. And E and rho is the constant. I will put it out. And we will have a y square dA. It gives us second moment of inertia. Last time I told you J, right? Right now I will write it like a inertia in z direction. Okay? You understand this one? So our formula will be changed. E multiplied by Iz divided by rho. 1 over rho. It gives us kappa. Curvature. So it is equal to E multiplied by K multiplied by EZ. From here, can I write K? Yes. K is equal to M divided by E multiplied by IZ. What was the formula of sigma x? It was equal to minus E kappa multiplied by Y. Instead of kappa, I will put this one. And it will be minus E multiplied by Y multiplied by M divided by E multiplied by IZ. E and E, young models, will be erased, right? And it will be, our formula will be changed. And this is the last conclusion. M minus M multiplied by Y divided by IZ. Do you agree? So, we will solve the exercise. Calculate the normal stress on a given cross section of the beam. First of all, we will do what? We will find the moment from where? Moment diagram. Last time we have learned how to draw the diagrams, right? It means that we will take from there maximum moment. Yes? What was the Y? Y is the distance from the neutral axis to the top or to the down. It depends on our question. And Z, we will calculate it. If it's a rectangle shape, we will calculate for rectangle. That's it. Yes, it's connected with moment. Bless you. If you have asked find the maximum normal stress, you will find just only this formula on a beam. Who will late for the class? Al Hojai, yes? And What was your family name? Lobik, yes. Yes. Did you finish? Can we move on? Yes. Here is given sign convention for moments. This part is wrong. Don't care about this one, okay? When I'm making the slide, I didn't change this part. I forgot. Just this part. This one was the last part. So, when we will have a positive M, when we will have a negative M. If our moment is acting in this direction, which upper part from neutral axis is in compression, down part is in tension. It means that our moment is plus. And vice versa. If moment is creating down part compression, upper part in tension, it means that our moment is minus. And this is the what positive internal bending can cause. Compression bending stress above the neutral axis. And the tension bending stress below the neutral axis. And positive curvature. It means that moment is positive, our curvature will be positive. If moment is negative, our curvature will be negative. Here, there is a bending stress conventions. Moment is affecting this side, our stress is minus. Our moment is affecting this side, it means that our stress is plus here, minus here. That's it. Did you understand? So, if you are asked maximum stress on a cross section, you will do what? Sigma max is equal to, it can be, sigma max, it can occur to the top and to the bottom if our neutral axis in the middle of the beam. So, S top, what does it mean? This one is Y from this formula, Y. Okay? Yes, top part. This one is Y. Y is the distance from the neutral axis to the top. And this one is the S bottom from neutral axis to the bottom. Yes? And we have one more thing. Section modulus. Section of modulus is equal to S. Section modulus. This one is S, okay? It's equal to what? S is equal to IZ divided by Y originally. By using this one, I can rewrite that formula. It means that our sigma x will be equal to what? Minus m over s. I'm changing that formula. This one. I'm changing this one. That's it. This is the end of our lecture. Next part, next class we will start the exercise. And before this one, we will do what? Quiz. No. It has. But it's very easy. That's why I will give you just half hour for 3 questions and 1 exercise. Half hours, okay? Yes, axial deformation and torsion. Not what? Yes, it includes in torsion. It includes here. What? 4. 4.